Hello all and welcome back to our session on finite automata. In the previous session, we had learned the definition of non-deterministic and deterministic finite automata along with comparing and contrasting these two machines. We had also seen the definitions of regular expressions, how to write regular expressions, some applications of those regular expressions, along with how to verify or prove the equivalence of two regular languages. I hope you all are excited to learn how to convert a given regular expression into NFA. There are two guidelines that we need to follow. The first guideline is about dividing a given regular expression into smaller sub-expressions to create NFA for each sub-expression using rule number 1, 2 and 3. Then combine the above NFAs using rule number 4. Let us see what these three rules are all about and then understand rule number 4 about combining these three rules. So here we have first rule for NFA for R is equal to phi. Phi is nothing but empty language from the definition that we had seen about regular expression. So here we will have a start state and a final state but not connected over any input. Then NFA for rule number 2 is NFA for R is equal to epsilon. Epsilon is nothing but empty strings. Since we are designing NFA with epsilon, there are going to be many epsilon transitions taking place in designing NFAs. And last rule is NFA for R is equal to A. A is nothing but the input alphabet that may be given or part of our regular expression. So here we will have a start state and a final state connected over A, and we have to take care that we divide our regular expression into sub-expressions and design NFA for each sub-expression using these three rules. For example, if we have a regular expression of the type A plus B, then we will divide this regular expression into sub-expression as A and B, and then we will see how to combine the NFA of A and B to make it NFA of A plus B. So let us see what is rule number 4. If we have the regular expression of the type A plus B, we have designed the NFA of A as a start state and final state over A. Then we have designed NFA of B as a sub-expression from start state to final state. And then we have these named as N of R and N of S for our reference for designing NFA or combining the rule number 3 of our regular expression to NFA. So here we will have a NFA of R according to our example, which will be NFA of A, and we will have NFA of B according to our example, which is nothing but N of S. We will connect them to a start state and a final state with or over epsilon. Do not forget to name your transitions and mention the arrows correctly because it is a directed graph which we need to take care. Because these epsilons and the number of states that we will have and the direction of the transition is going to help us convert our given NFA into DFA. So let us check what is rule number 4 part 2. Part 2 is about R dot S, that is a regular expression of the type A dot B. The sub-expressions will be A and B. So NFA of A again will be a start state and a end state or a final state over A, and NFA of B will be a start state and a final state over B, which will be representing N of R and N of S respectively. Now when we have to combine these two sub-expressions and create the NFA for A dot B, we have to make NFA of A, that is nothing but N of R, and NFA of B, that is nothing but NFA of S. So here we will have these two NFAs placed one after the other, and out of which N of S will have its last state as final state, and we will connect these two states with epsilon, and the first state of N of R will be our start state. So here there is another way of writing or drawing the NFA for R is equal to R dot S, that is we will have N of R Then we will have n of s which will be overlapping n of r and a start state. Here this short method will help us reduce the number of states when we will be dealing of converting a NFA with epsilon to DFA. So in case till you get the hang of how to draw NFAs for given regular expression, you can use this longer method. In case you already are an expert, you can always go with the second way of drawing NFA for R dot S type of regular expressions. And finally, NFA for R is equal to R star, that is LR star. There we will have a expression of the type A star. So here we already have the regular expression A converted into NFA as start state and final state connected over A. This is nothing but n of R. So here we will draw n of R and then add two states, that is a start state and a final state at the beginning and the end of our n of R. Then we will connect this with epsilon from start state to the first state of the n of R. Then this n of R's last state will get connected to the final state over epsilon. Now for R star, that is a looping that we need to take care, always remember that the last state will get connected to first state of n of R. That means in our example, the final state will get connected to the first state, that is start state of A. So here this will be the self loop that will take care of the star closure, that is I running from 0 to infinity, right? And another transition that we need to take care is from start state we need to connect the final state over epsilon, since star produces epsilon as one of the empty strings. Epsilon is one of the smallest valid string which needs to get validated via NFA. So from start state it will directly go to final state without traversing through the n of R. Let us solve some examples. So first we will write or draw the NFA for R is equal to A. So here we will have A. Do not forget to name our states, since we will be using these state numbers when we will start the conversion of NFA to DFA. So here we will be having 0 and 1. Again we will have 0 and 1 as the states for B. So this is our R of R is equal to B NFAs. Then we have R is equal to A plus B and R is equal to A dot B. So here for A plus B we will have the NFA of A, but here NFA of A will not be treated with a final state as the second state. We will have NFA of B. Again there will be no final state for A, the second state of B. We will add a start state and a final state at the end and the beginning of our NFA. We will connect this A's and B's regular expressions over epsilon. And finally, we will start naming our states 0, 1, 2, 3, 4 and 5. Now for A dot B, we have the regular expression. For the NFA will be, we will have NFA of A and B. I am taking the shorter method for writing down the NFA for A dot B. Another way of writing this NFA is a longer method. So in that we will have NFA of A and NFA of B. So here NFA of A first state will be our start state. We will connect these two over epsilon, and the last state of NFA of B will be our final state. So here there is one state getting increased, so we will have total 4 states, and in shorter method we will have 3 states. Let us take another example. It is A star. So now we can see that we are slowly beginning to increase the complexity for converting our regular expressions into NFA. So here first we will draw the NFA of A. Then we will add two states, that is start state and final state at the start and end of our NFA. We will connect them over epsilons. Now if you remember, we have to draw two loops. One will be a self loop of A starting from the end of NFA of A and to the start state of our NFA of A, and connect the start state directly to final state over epsilon. Do not forget to name your transitions. Now A dot A star, that is A plus transition. So for this we will have an NFA of A, then we will have another NFA of A, because it is A dot A star. So here we will have a final state and a start state. We will not need a start state. The start state will be the first state of our A, NFA of first A. So here this will be our start state. This will get connected since it is a dot over epsilon. Then from this state we will directly reach final state, and this will be connected over epsilon, and it will be a self loop for A. So here 0, 1, 2, 3 and 4, that is 5 states are there altogether. So what did we do here? We first drew the NFA of A, then another NFA of A, both connected over epsilon, and the first state of first NFA of A is our start state. We added a final state at the end, a self loop for second A, and from this last state of A we took the transition to final state directly. Let us see one last example for this session. So we will draw the NFA for A plus B. So for drawing NFA of A plus B star, first we need NFA of A, we need NFA of B, we add a start state and a final state for A plus B connected over epsilon. And finally, for closure, that is star closure, we need to add a start state and a final state at the start and end of our NFA over epsilons. Now for star closure, we have to connect the last state of A plus B to the first state of A plus B over epsilon, and from start state to final state, direct connection over epsilon. Start naming our states 0, 1, 2, 3, 4, 5, 6 and 7. I hope these NFAs were simple enough for you to understand and get a hang of how to draw the NFAs for converting a regular expression into NFA. If you want, you can try out these two regular expressions to convert it into NFA, and we can see the solutions in the next session. In case you have any doubts or any queries regarding today's session, you can leave it in comment section and we can get it clarified in our next session. So see you then.